Okay, great. Hi, everybody. My name is Ryan Crichton from GMB Health Systems. Today, we're going to be taking everyone through a demonstration of the MVP that we've developed for DISI, along with some of the DISI architecture for context on how this all sort of fits together and works. So um, let's jump right in. So what's the end goal? The end goal is really to go from a point of care or point of service, I think I should have said there rather, point of service application to something happens in the middle, and we end up with some nice dashboard like this um, on the end. So what I'm going to explain is what sort of this thing that happens in the middle is to get to this sort of point. But just to show you up front, this is what we're sort of getting towards. So this is Kibana. This is the dashboard we put together for HIV case-based surveillance. You can see it has a number of graphs, some numbers, maps, various things that show countries' progress with their HIV epidemic, for example. So this is what we're getting data prepared for, is this sort of reporting. Okay, so now we're going to go back and see how this is actually made possible through this MVP reference implementation. Okay, so let's start first with how the data is structured from the point of service application. So we defined two formats. There was a simple format and a more advanced format. So in our case, we chose to use FHIR. So what this means is there's a certain set of profiled FHIR messages that we need to prepare to support those two formats. So on the left, this diagram that you see is how those are prepared. So firstly, we start off with a minimum data set. In the case of this HIV case-based surveillance use case, this minimum data set is something that the UCSF team put together and provided us with. And that's fed into, the idea here is that would feed into a working group, which would then try to convert that to a FHIR implementation guide. So what is a FHIR implementation guide? So that's basically just a set of narrative content about how you use FHIR, as well as very formal profiles of exactly which elements in the FHIR messages to use. So it basically specifies exactly which bits of FHIR to use for a particular use case, for a particular set of data. So the FHIR implementation guide provides profiles for these sets of things. So the simple format we chose was to just use a questionnaire response. So this is a very simple resource to describe. It's just basically all the data that you can describe in the minimum data set can be put into the questionnaire response and sent as one single thing, and it's very straightforward and easy. We also, on top of that, describe how to represent that full minimum data set as individual FHIR resources. So this could be like a resource could be like a patient, an observation, an encounter, a care plan, all these different types of concepts that together makes like a bundle of clinical data. So this gives you a lot more control about exactly what gets sent. So this is the advanced format. So it's a bundle of individual FHIR resources that are described. And then once we have this FHIR implementation guide defined, that can go to the point of service systems developers and the developers of the data pipeline to understand exactly how to transform the data and how to prepare the data to be used within the architecture. So here's the minimum data set that we got from UCSF. So basically the job was taking this table of all these this data and trying to fit it into FHIR. And this is an example of the built website for the FHIR implementation guide, which then describes exactly how you use FHIR, like how you submit case reports, how you construct a FHIR bundle, how you could possibly use CSV in the very simple form, and that sort of thing. And it goes into some pretty minute detail on how to exactly structure all of the FHIR representations. So there's examples of the full fire bundle that can be seen, like the JSON format of the full fire bundle. So this is how what you would construct to send as a point of service system. And it also describes, find an example, the individual profiles of exactly what should go into each of the resources that are sent. So you can see this describes like what is mandatory, like name and date of birth, for example, and what are some extensions that we've defined to capture key population status, for example. So it goes into quite a lot of detail, and that maps directly to what comes from the minimum data set. So that's about how you get data from the point of service application. I have a tool here called Postman that's going to simulate the point of service application, and we're going to try to send some data through into the rest of the architecture to see how it flows through to that dashboard. So you can see I've got this Postman tool loaded with that full fire bundle of clinical data. This generates some random data for me, like random patient names and random date of births and etc. So this is what I'm going to use to try to simulate sending data from a point of service application, and we're going to see it flow through the whole system. So if I hit send here, I have this whole system running in the cloud at the moment in our sandbox. You see it's now come back and that's been successful. So let me show you where that went. So the next step along in the architecture is for this to go to the interoperability layer. So you can see from the simple or advanced format, it goes through the interoperability layer, and then we'll get into this orchestration bit in a second. But here's the interoperability layer, the OpenHIM that we're using in this case. So this checked that the message was authenticated, and you can see the message came through here on top. This is the bundle that I just sent in. All right. Okay, so now that we've got data being sent in, that's being submitted through the interoperability layer. The next step is we go through this orchestration bit. So these bits circled in green. So this is our orchestration to the client registry. So this is probably one of the most important parts to try to detect if we're getting duplicate data in, or for example, a patient has been submitted from facility A, but has also had sort of the same data submitted from facility B. We don't want to be double counting them. So this is how we go through that. So every bit of data that gets sent, whether it's transactional or batch, gets processed in this way. We first check if that patient has an identity that already exists in the client registry. So we do a lookup in the client registry to see if their identifier is available. If they don't exist yet, we then create them in the client registry. Once they've been created, we get two identifiers back. We get a source ID, which is basically what is the ID for that record in the client registry, as well as a golden ID. So the golden ID is if patients are then linked together they're found to be actually the same. They were just submitted twice. They could be grouped together under a single golden ID. So it's like a grouping ID for different records. And then we take those two identifiers and add them into the bundle that we have. And then that gets submitted to the shared health record and stored. So we end up with the patient demographic information in the client registry and the clinical information in the shared health record with just some identifiers linking back to which record it was. Okay, so that's the process it goes through. So you can see I've got this is the client registry tool OpenCR that I have running here. Refresh it. So you can see all the patients that have been registered so far. So far I've got 2001 patients registered. You can see, I don't know if you can see that text, but there's 2001 patients that are registered. So I had 2000 before and I just sent a new one, so that's 2001. And then you can see some of the patient details, the demographics, some of the identifiers that are used. And right now, this patient is not matched to any others. It's just a single patient record. It wasn't detected as a match. Later on, I'll show you how to some matching and how that affects things. But that's enough for the moment. Okay, so a little bit on how those matches happen. So there's two ways that we can do matches, or that patients get linked together. So initially, if they just get sent in and there are no matches, what you end up with is a patient record, like we have on the top left here. So Jane Smith is a patient record, and they're linked to just a golden ID. That's it. So they have one source ID, one golden ID, and that's the end of it. Then if we have a second patient come in that looks very similar, based on some rules, which I'll touch on in a second, how we get to those rules. If the rules say that those patients should be automatically linked, they're close enough that we think that they're pretty much identical, and should be counted as the same person. What will happen is on the create of that patient in the client registry, they'll then be linked under the same golden ID, but the two source records will still exist. So if there's minor differences, like maybe a misspelling or something, those would still exist as separate records, but grouped under this golden ID. And the other way that it can be linked is if they are created individually, so one patient already exists, the second one gets created, but the client registry notices that they're kind of similar, but it's not sure if it should link them or not automatically. It's not as close a match as it was for automatically linking. So what will happen then is we'll have the system will flag these as a potential for linking, and then someone can go in and choose to link those records together later. And what will happen is we discard one of these golden IDs and link them under the same grouping ID again, so that they're now counted as the same identity. And that's what the OpenCR tool does. So basically, once we have these links and things are managed completely by the client registry, all that the rest of the solution cares about are the two IDs that come out of it, the source ID and the golden ID. The golden ID we can use, for example, to in our reporting system to make sure that we're distinctly counting records. So what that means is that we're not counting anyone with the same golden ID twice. Anyone that has the same golden ID is only counted as one. And we'll see that working in a little bit. Okay, so then the next thing is, so how do we get to that configuration for OpenCR? So OpenCR is configured by following a particular process outlined in the patient matching toolkit that GMB has put together. So this is something that Laura is going to be talking on in another presentation, I believe in 2 weeks from now. So if you're very interested in that, please attend, and we'll take you through the detailed process on how to get to that. The basics of it are that there's this evaluation process that takes place by looking at your data, running through some example scenarios, and getting in some outputs, and then that will generate your optimal config for OpenCR. So you run through some tests, basically, with synthetic data sets, and try to get to what gives you the maximum amount of duplicates that are found. And then once you have that optimal configuration, we use that in OpenCR. So yeah, stick around. Well, be available in 2 weeks' time if you want to hear the details of that. It's very interesting. Okay, so now we've gone through having the data submitted, goes through, the data gets added to the client registry, the demographic data. The clinical data gets added to the shared health record. From there, we have this Elastic Stack data pipeline, which takes the data and transforms it and puts it into a data mart. So in our case, this is HappyFire acting as the shared health record, Logstash acting as this data pipeline, which does the transforming of the data, joining of records together, and the data ends up in the data mart, which in our case is Elasticsearch. So an Elasticsearch database. Then we have some visualization tools built on top of that to actually pull the data out and show reports. So that's Kibana, and we also have a tool called JS Report to do some more advanced custom reporting. So that's the basics of how it works. There is a more advanced description in architecture docs to go, which goes through exactly how the transformation of those Logstash, those fire resources are done in Logstash, if you want to go through that. Okay, so then what we end up with is this this real-time dashboard that I showed in the beginning. So what I'm going to do in the background is quickly just kick off a script which is going to run Postman and keep running it over and over again. And what we should start to see is new data coming in live. So the nice thing about this is it's all happening in real time or near real time. So what's happening right now is I'm sending data from the Postman script. It's being sent through, added to the client registry. So you can see as the script is running, we're getting more and more records, 2058, 2064. So it's registering patients. OpenCR is trying to do matching where it can. And we're seeing this data be transformed and flattened and put into a Elasticsearch, and this is all being updated then live. So what you can do on this dashboard, so this is Kibana, is the tool that we're using. You can see I'm showing data for the last 10 years. You can also define some custom time periods, like, I don't know, second quarter of 2021. You can see the data just for that, or for the whole year of 2021, or whatever you choose. You can do custom date ranges or just last 15 minutes. Probably won't show anything. I'm going to go for the full data set. Okay, so here we have, so I've been showing the live dashboard. I just stopped it now so that we have some numbers we can stick with. What I wanted to show next is also then, so we have live numbers updating in real time, but I also wanted to show what happens in the client registry. So if we have certain patients being registered, and those are potentially being matched. So right now you can see action required, there's nothing listed here. So that means there's been no patients that have been detected as a potential match just yet. But I'm going to try send some in and fake some duplicate records, and we can see what happens. So let's just go back to the dashboard, make sure I've got the latest numbers. So you'll see that this currently says 2,752 HIV positive people. So we're going to see if I now send in some duplicates, what happens. Okay, so I have some, again in Postman, I've got some pre-configured bundles set up for patients that I know are going to match. They've got very close demographics. So I'm going to send those in. So there's match number 1, we send that one, and then match number 2. So I know that those patients are pretty much identical. So what's going to happen is that OpenCR is going to detect that, and it's going to log those, automatically match those 2 patients together. Let me find that person. John Smith. Okay, so we see that now we have John Smith here, but now they've matched with John Smith, so John without an H. That's the only difference between these 2 records, is one had a given name with John with an H, and then one John without an H. So you can see those automatically matched together. So what's happened in our dashboard? Remember, we had 2,752. If I refresh this, it should be 2,753. So even though I've submitted 2 completely separate records, it's only gone up once because the client registry has caught that, and their golden ID became the same, and we're only counting patients that have unique golden IDs. Okay, so that's the one way. The other way is I have a third patient I can send in that is kind of close but has some differences. So now that I've sent that in, if I go back to the client registry, you can see that there's 1 under action required. So this is another patient I've sent with John Smith, but it's Jon and Smith without an I. So missing an H and missing an I. So it wasn't quite sure if these were a match or not. So now this appears in OpenCR, and it asks you what to do. So if I click on that, I can say, okay, I can review it, have a look at the demographics, or maybe, I don't know, make a phone call, do something, and then say, okay, I actually think these are all supposed to be the same person. It was just a typo from 3 different facilities or something. So if I then try to match those together, before I actually do the match, let's see what happened on our dashboard. So you can see it added 1. So now we're on 2,754. Because that was seen as a new person. I'm now saying, okay, actually, those are all the same. Save those changes. So what this does in the back end is it makes them all have the same golden ID, which is this identifier here, which should then, in a few seconds, update our report back to 2,753. See if that worked. Okay, cool. So then, and that went down again. So this shows how we're approaching some of the deduplication as well.